Welcome guys for December's Dr. Spotfire. Today we are going to cover scaling of Spotfire, which is very interesting and very important topic. Um, as always, Dr. Spotfire is learning is not driven by answers but by questions. Today we are broadcasting from Boston and it's snowing crazy here. Um, the next session will be Python data functions and Spotfire X, which will be really interesting. And our own Dr. Spotfire team member Neil is going to cover that. It's on January 7th. Um, Please try to join that as well. It will be really interesting and a cool session. Um, we are trying to be very active, try to share all the content we are creating around Spotfire on different groups on Reddit, Facebook, and LinkedIn. And we will post the links to join those groups on the chat shortly. Today's session will be, as I mentioned, scaling of Spotfire, and our senior architect Peter McKinnis is going to cover that. Without wasting any more time, I am passing the sharing to him. Peter, floor is yours.
Okay, thank you, Ninad. Let me get started here. Yeah, so we'll go through some slides and we'll show a little bit of things within the environments that we have, and so let's get going. So first off, we'll kind of go through. We'll kind of do an architectural review. We'll discuss kind of what goes into scaling, and then we'll kind of focus on a couple of the various components. And any time throughout, please ask questions, and we'll get to them. So first off, what to get out of the presentation? I hope that everybody learns something new, get some pointers to resources that will be helpful, some strategies and information that will help you size and scale your environments. What we don't have is we don't have some secret magic formula for computing, and knowing how to exactly scale and size an environment. But hopefully you'll get some good pointers and good information and knowledge that will help you in sizing and scaling your environment as you go forward. So first off, we'll talk about the Spotfire architecture just as an overview. I won't spend a lot of time on this, but just to, when we're talking about scaling, what are we talking about? What affects that as far as the architecture goes? So first off, we'll talk about the clients. We have the Spotfire Analyst, which is the thick client. In that case, most of the work is being done within the user's desktop or laptop. They do communicate some with the Spotfire server, but not much. The consumer and business author and the mobile access, those are both browser-based clients. And in that case, all the work is being done on the back end on the servers. So all these communicate with the Spotfire server for authentication, authorization, access to what we call the Spotfire library, where all the artifacts are contained. In addition to that, the consumer and business author and mobile devices, they communicate and also work with the web player. So the web player is where the Spotfire analysis files are hosted while the users are interacting with them, and all that traffic is going through the Spotfire server. So that kind of gives you a sense of what we're talking about when we're talking about scaling the environment, what users affect what, and what items affect the various components within the environment. Now we'll go into a little more detail about each of these things and kind of what affects the scaling from a perspective of the items that do that. So first off is the users. So we've kind of talked about that a little bit. So we have the types of users, the number of concurrent users. You have a total number of users. If you can either have the total number of users or concurrent number of users. If you have total number of users, we can kind of estimate the concurrent number. It's usually 10 to 20% of the total. That can vary, obviously, if you have some sort of maybe monthly or weekly type of report where a lot of users may be accessing it at one time. So as far as the analyst users, they talk to the Spotfire server. Again, they don't talk to it that often. When you're loading an analysis file or pulling data via the information services via the Spotfire server, they'll be affecting or connecting to the Spotfire server, pulling stuff from the library, initial authentication and things like that. So they don't. Most of their data and everything is being done on their laptop and desktop, all the calculations, everything like that. So while they do affect the environment, and it is important to know the amount of analyst users, they don't affect the environment as much as the web-based users. Also, usually the analyst users are a small, they're not as large as the other user base. So then we have the business authors. So those are the ones that can do some authoring on the web as well as look at the analysis files within the environment. And then the consumers, which consume the analyses on the web. And again, those all talk to the Spotfire server for the initial view of the library, looking at the library before they select an analysis file. And then those analysis files are brought into the web player, and that's where all the hosting is being done there. So again, that's kind of just so we need to know, the number of users, number of consumers and business authors and analysts that are in the environment is a good one of the metrics that we need to know to help with sizing an environment. Another useful bit of information is the size of data. Now we'll kind of start off at a high level, and we'll kind of drill down into this a little bit. And again, this also depends on how one is consuming the data. So one is if the amount of RAM used by the data within Spotfire. If you have a Spotfire analysis already available, you can estimate. You can also, if you have an estimate of the number of rows and columns within the data, you can kind of get a good idea of maybe how much room the data is going to take up. The estimated database size of databases. Relative size can also be useful. We're talking about hundreds of millions of rows, a billion rows, hundreds of thousands of rows, things like that. Also, the data size, large, extra large, down to small. Obviously, some of these data sets up in the high range, they wouldn't all be brought into Spotfire. You would consume those in a different way. You would do something different with those besides bringing those all into memory, at least into Spotfire. You'd bring them in as pieces and things like that. So the next bit of information is how you can consume data within Spotfire. So the first bit is, in memory, you're going to pull data from the database and put it into memory, or you're going to, maybe keep the large amount of data and just pull in a little set of data based on a visualization. So with the external data, in that case, you're sending a query down to the database and only pulling back the data needed for a visualization. So for example, a bar chart that has 10 bars on it. You realize in the simplest way, you only need 10 pieces of information. But you could have millions and billions of rows of data in the database, but you'd only need 10 pieces of information to draw that bar chart within the Spotfire environment. Whereas at the in-memory case, you're pulling back, you have all the data and you're doing the calculations in there. With the external data, you're pushing the calculations down to the data source and only pulling back the data that's needed. So it allows you to work with larger data sets within the environment. Another way is on demand, which is usually customers you may start out with a aggregated data set and then be drilling down into the detailed data. In that case, you're swapping the data in and out of memory. So as you work with the data, maybe find some outliers, choose some points, use those, and then drill down into the details, either a detailed visualization or a table of that data, things like that. In that case, you're not pulling back the whole data set into memory. You're pulling back subsets based on the selection. The last thing that's been added in recent versions is streaming data. So this was initially introduced in the Analyst in Spotfire 10, and then in the recent 10.6 release, it's been added to the web player. So that should be as a consideration also, as well as how the data is what type of data is being used. How is the data being consumed within the environment? So if we're looking at it, we'll kind of focus a little bit on in-memory data specifically for a few minutes. So one of the things, if you already have a Spotfire analysis available, you can estimate the RAM needed using Spotfire Analyst. So you can initially look at how much the Spotfire analysis, how much Spotfire itself is taking up in memory. So we'll flip out for a second and look at this within one of our environments. So I've started Spotfire Analyst already. We can see it's taking up, about these are sub processes of this Spotfire analysis. So we see it's taking up about 200, maybe 210 megs of data. So we'll pull in an analysis file, and then while this is pulling, we'll actually go back, and we won't wait for it. We'll come back to it in a few minutes when it's done. But I'll go ahead and pull this in, and we'll let that start while we go back to this slide deck for a minute, just to get a sense of what's going on. So again, if you have a Spotfire analysis already, you can start up Spotfire Analyst, see how much data it takes up with nothing loaded, and then you can load the analysis file. And again, we'll see how much, see what it takes up in this example. Well, I said I wasn't going to give a formula. I mean, this is just kind of a basic, high-level, simple formula to use to kind of get an idea of how much data and analysis, or how much memory an analysis file would take over in memory. So the initial, there's initial kind of the base size of the data, and that's usually the largest piece of it in most cases. And then there's each assuming the users can share this data in memory, the next piece of data is each user kind of has their own memory footprint. So this kind of is affected by the number of pages in the analysis, the overall complexity analysis as far as what we call filtering schemes, so the number of different ways you can filter the data within the various pages. So each, there's that user data, and then you can multiply that by the number of users, and that gives you the kind of a high-level amount of the memory needed. Obviously, this can vary greatly, and it's not always this kind of again is a high-level estimate. Seeing what's going on in the environment, monitoring the environment is the best way to get this to kind of see over time what happens. Typically, the user data typically is between 40 and 80 megs, depending on the analysis complexity. I do a lot of performance testing, and that's kind of where things fall. I have seen some that go up as high as 100 megs. It kind of depends again on the complexity, the amount of data that might maybe you're bringing a lot of on-demand data in, maybe you're doing something else that is making the user data take up more than is typical. So in this case, if we had an assumption of if we do the math for this, it's about 1.9 gigs, and then we have if we estimate about 60 megs for each user, and then we have 100 users concurrently at one time, then that would need to take about 7.9 gigs for that. So again, this is a really high-level estimate of the amount of memory being used when you're doing the in-memory data. So let's just to give kind of a sense of how difficult this can be, or how it's not always there's not always a linear mapping from the number of columns or rows to the amount of data. It's just to give you a sense of some data sizes I've brought in. The one we're actually bringing in right now is just 1 million rows and 100 columns. You can see it typically takes up about 2 gigs in memory. I also listed the size in SQL Server database. But this other one that actually has more rows but fewer columns, so the number of cells, the number of rows times columns is fewer. It takes up a lot less, even though it has more rows, but it does have fewer columns. As we look down this, we see another one. This is an interesting comparison. This actually has quite a few, 400 million cells versus 135 million cells, but it's actually the 400 million is actually smaller. Probably one of the couple of things that affect memory, the in-memory data, is the entropy of the data. So how many unique values are in a column? If you have a column with a few unique values, then it takes up a lot less space than one with many unique values. I didn't go and look at this data specifically, but my assumption or thought is that between these two data sets, the second one has a lot more unique values. It's actually from a database benchmarking test, whereas this other one is actually the 1, 3, and 5th row are all data sets that have been created for doing performance testing, so they might have fewer unique values in the columns and just have a lot of data in there, but not as many unique values that take up more space. So again, this kind of gives you just kind of an overall sense of how data can be spread out. This last one has 1 billion cells. So the number of rows and columns is important. You could have a 100,000 row data set that has 1,000 columns that would take up more room than something that's maybe has 1 million rows but only 10 columns or a fewer number of columns. The other thing that's important is the data types of the columns. So the character numeric number of the size of the column as far as the number of characters is also important. So let's take a moment and flip back and see if the our analysis is done loading, and it is indeed. And so we go back over here and we see how much you know it's taking up. You know, before it was taking about close to 200, a little over 200, and now it's taking little 200. It's 2 gigs and about 200 megs, so 2.2 gigs. So that, again, it takes up about 2 gigs. Again, this isn't a hard and fast rule. It might change. You can see it's even changing right now, even though I haven't even touched the analysis file. But if I start to manipulate the analysis file, it might go up or down, based on what I'm doing. So it's not, you're not going to, it's not an exact amount, but it gives you a good idea of the amount it'll take up, the amount of base data that it'll take up.
Hey, and Peter, this is Neil. We have a couple questions in the chat.
Okay.
I'm sorry to interrupt, but it might be good to cover a couple of these while you're on the topic. Joe was asking if clustering influences the sizing, and is load balancing causing the overhead, or can they split the figures mentioned? So for example, having 2 servers having 16 gigabytes and 2 CPU each, instead of 1 server having 32 gigabytes and 4 CPU.
Yeah, that can be helpful. Assuming you're talking about load balancing, you're talking about the Spotfire load balancing the Spotfire server. But yeah, so you can split the load. It kind of depends on if you're needing to do high availability and you need such that you need both available. Like if one goes down, you still need to service the same workload. Then you might need to keep the same size of each. But as far as the Spotfire server goes, having something with 2 to 4 CPUs and 16 gigs or 24 gigs, is good. But as far as the clustering, you can split that in half, like you're talking about doing, but you still may need a base amount of 16 gigs on both. Or if you need high availability and you're hitting some limit there, then you might need to go up to like 24 gigs or something like that. I hope that answers your question. It's not always you can't always split it in half. It kind of depends on what people are doing, but it's also, as far as the Spotfire server, the main thing that affects its size is again the number of web player users or consumer users, business authors using the web player, but also something that really affects it. And when we talk later about Spotfire server, we'll talk about it a little bit more, is also the number of on-demand queries. So, or the number of queries in general, but also I've seen some customers that have, so they'll start out, their analysis file will be loaded. The first thing a user does is make some kind of filtering type choices, regions, some choices about specific data they want to look at, and then they click a button. What that does is, behind the scenes, is it sends off a bunch of on-demand queries to the data source and brings in this specific data that they've filtered to. Well, that can put a heavy load if you say have like 10 on-demand queries and you have like 20 people doing that at one time. That's 200 queries that could happen at one specific moment, and so you have to have the servers, and splitting that type of load across 2 servers gives better performance than having one large server. So
Okay.
So yeah, is there some other questions?
Yeah, I think I'll take like one more for now, and then I'll let you move along. So for context, are you running? How much RAM are you is on your Spotfire server now? Or you're not running the Spotfire server on your local machine, are you? Are you?
No, I'm not. No, I do run it on my local machine sometimes, but not right now.
Right. So for the context of the demonstrations, how much RAM are you using with Spotfire server for this, so they can get a sense?
Actually, that's a little bit. I have 2. Anything I'm showing here, or some of the things I'll be showing here on, I have actually 2 blades within the office here in North Carolina, and they both have 128 gigs of RAM on them, which is way too much for Spotfire server. It never uses more than just several gigs of RAM. So that's kind of the actual number of the JVM size for the Spotfire server on the machine is only 4 gigs right now. So that's the most it'll use.
Okay, that makes sense. It's a little bit of an unfair comparison, but you're not in like a realistic scenario. But although 120 gigs of RAM would be nice for all our Spotfire servers.
Yeah, yeah, it never uses that much, but and we can look at that Yeah. So just the last thing about what goes into scaling, we kind of talked about memory and users and data and things like that. The last thing really is the analyses and what's kind of going on with them. And this kind of can affect CPU more than other things, but
okay.
Yeah.
And sorry, I think there's one other question, might be a quick one. Using filters, how does that affect RAM usage? Using data versus filters?
So the filters themselves wouldn't really affect the base data, but what it does affect is it affects the user data. So so if you have if you're familiar with filtering schemes, those are where you have different filtering on each page or on a set of pages, and each one of those, I'll have what I am filtering to, and another user will have what they are filtering to, and that'll affect how much the user data is, but not necessarily the overall base data. Assuming you have everything in memory and you're not filtering the data as you pull it in. But if you already have all that base data in memory, that'll affect the user data and how much what Spotfire needs to hold on to know what I'm doing, because if there's 5 filtering schemes, it has to keep all that information in memory.
Okay, thank you. I'll let you continue on. Yeah.
Okay. So yeah, so the next thing is the analyses themselves. So the number of analyses. What is the largest analysis in memory? So that's important if you're, if you have a really large analyses or some analyses that are really large, you may need to have those on their own web player, or you don't want to have a web player with 32 gigs when someone's brought in 64 gigs of memory into one analysis file. But you can have web players with different sizes, and they don't all need to be the same amount of memory on them. Complexity of analyses, so this affects, again, kind of back to the CPU, the calculations, scripts, IronPython. The TER and statistical scripts themselves would not be run specifically on web player, but those would affect the kind of the CPU, the fact that that data goes out, is sent to the TER service, and then when it comes back in, Spotfire has to process that. The other thing is analysis preloaded by scheduled updates. This can save a lot of CPU. I've done performance testing on this, and if you don't load the analysis with scheduled updates, every user takes almost like 1 core of CPU to load the analysis. Obviously, once it's loaded, there's not that much CPU being used, depending on what the user is doing, but loading the analysis can take a lot of CPU. So if you can load something in scheduled updates, it can save a lot of resource power for other things. Again, this is recommended for highly used analyses and important analyses. The last thing, kind of more geared towards the analyses, and we kind of talk about, is data shared by users. So this is obviously reduces the memory footprint in web player. If I'm using the same data as someone else, we don't have to have, or if we all have our own data, then you have to keep that in mind. But if we can, all be sharing data, then that obviously reduces that memory footprint. And web player is really intelligent and optimized behind the scenes to, or under the covers. If 2 people actually do bring in data that's not already loaded, but it is the same data, then it'll throw out one of those and optimize that usage in memory. Last thing is there's a link. You can set up this. You can do caching and scheduled updates and share data in row level security scenarios, such that when the large amount of data is already loaded, but when a user logs in, it goes and gets the information about what they can see as a user, and that just pulls that subset or doesn't pull the subset, just takes a subset of the data, keeping the larger amount of memory still in memory, but gives the user a pointer to the subset they can see in memory. So one thing before we go on, I know we're getting short on time, and I did want to show. Some of the stuff we'll talk about, but I want to go ahead and skip kind of down to the performance issues in the environment. I have right now. I'm actually currently running a performance test just to give us something interesting to look at. But there are several different ways to look at performance within the environment. So you can look at it, what's going on right now. So this is the monitoring and diagnostics of the Spotfire admin web UI. So you can see what's going on now. We can refresh this. last time we refreshed it was before we started the Dr. Spotfire, and you can see that I'm actually running up to I'm going up to 500 users over an hour. So now we're getting pretty close to that. So this is kind of a high-level view. We can look at the specifics of the Spotfire server, and in this case, it's really only being utilized as for the HTTP traffic that's going through it. The data, this analysis file that I'm working with, has already been loaded in web player in memory and using scheduled updates. But the more important thing to look at is the specific instances. So we can see we kind of have a high-level overview. I can go down to details. This may not be useful or not, because there might be there's just like several hundred of the same analysis file. But one of the other interesting things is the performance counters, and there's some links in the that I have in the slides here about more detailed about this. One of the interesting a lot of these are memory and CPU, total number of users and other information. One of the things that is interesting to look at as far as this goes is the paged in and paged out, which actually we don't have any yet. So paged out memory and paged in memory. I was hoping we'd have some by this time, but we don't yet. But the other thing is, while we're on here, there are a couple different types of memory used within Spotfire. So there's the base memory that is used by the data, and then there's a query cache memory. So this is as users do things within the environment, their action is considered a query within the Spotfire data engine. So if I filter something, internally that's a query to the Spotfire data engine, and that result is cached within memory, and that'll be the first thing that's actually paged to disk when the memory gets when we start to run out of memory. But it's those results are cached into memory, so it makes it faster for that retrieval. Assuming you might want to do the same thing again, or maybe there's another user within the environment that might do that same action as well. So this kind of gives you, the monitoring diagnostics gives you a current view into the environment. As you can see, there's pluses and minuses here. So if I go up here and refresh this, it'll update them and then see what's things are going up or down depending on what's going on. Well, the available memory is going down, amount of memory being used is going up. So this is a snapshot of what's going on right now. There's a couple other different metrics and ways to look at data that's or performance metrics that are historical. So we have we'll start with the user action logs. They're really important, and they give you a good sense of, they do have monitoring information in addition to all the other user actions that they capture. They also do monitoring. So this is I haven't refreshed it today yet, but I was doing testing last week before the holiday, before the U.S. Thanksgiving holiday, and so you can see here some spikes in memory and in CPU and things like that on the web players. So this is the web player monitoring. So this again gives you a kind of historical view. It gives you about I don't know, there's probably about 10 metrics here. And the last bit of information. So this gives you a good overview. You can see when things are happening, and then you can use this in relation to the other user actions. The last piece is the performance counters. So these are very detailed. There's a debug. There's an info level of performance counters that is recorded automatically, and there's a debug level that can be set up to be recorded as well. So you can see here, actually, I already scrolled down. Here you get a lot of the performance metrics that you get on the other page. Here you can see some paged in and paged out. One of the things is here, it's not so bad to page in and page out. If these were closer in value, you can see they're different scales, unfortunately. But so about half maybe of the data that was paged out was paged back in. If these were closer to 1-to-1, then maybe that means you're running out of memory. I know we're getting close to the 12:30, but I'm willing to continue.
Peter, it's fine.
Talking.
It's really interesting content. So everyone, Peter might have some more information to give. So whoever want to stick, we will continue this session. So yeah, thanks, Peter.
Okay. Are there some questions we should get to? Should we take a little break and take some?
Yeah. So Peter, there was one interesting question, excuse me, about auto scaling when there is a when there is a load, and shutting down the machine when there is no load. So especially in cloud installations. So do you have any
Right.
interesting?
Right. Yeah. So right now, yeah. So you can scale up fairly easily. You can silently install web player or services or the nodes, and then have a web player service installed on there without any user interaction. Automating that process. It's a little more difficult right now to scale down Spotfire. I mean, you can set a node to be if I go back to this is easier to show in here. If I go back to the nodes and services here and actually click on one of these, so I can schedule a time for this to shut down, and it won't put any other users on here, but it doesn't take them off. So if I schedule it for I don't know, in 6 hours and there's still users on it, those users will be kicked off. So we can scale up fairly fairly easily and automated, but it's a little more difficult to scale down at this point. But yeah. So we can do scaling up. Any other interesting questions you want to take right now? Or?
Yeah, Peter, there is one more just came in. What drives the performance of like drawing markers on charts, and like what would you do to improve that? Anything regarding the future? And the question was especially about map chart and markers and features on map charts.
Yeah, I'm not as familiar as map charts, but just in general, as far as the performance, the things that affect it obviously is the calculations underneath it. So if you're marking something and that's kicking off maybe a bunch of calculated columns or custom expressions, and if those are really complex or working with millions and millions of rows of data, then that can be that can cause performance. Sometimes it could be. I mean, obviously there's a couple of different things. There could be there could be a resource issue, and that you can look at to see if hardware and if the CPU and memory are being taxed. And if that's not the case, then you need to look at the analysis itself. And is there any way to maybe simplify some calculations, maybe limit the data that's being shown the user, or something like that. So that kind of, I know that's not specific to the map chart, but that's just kind of general performance things with Spotfire.
And there is one more, sorry, this will be last one, so you can continue. But are there any tools which could be used to benchmark web player performance?
Yeah, there are. There's nothing that we have publicly available right now. In fact, what I'm using right now is, and we could probably have a whole Dr. Spotfire on this, but what I'm using right now is a web player load testing tool that we maintain internally, and our services group has used at customers. Basically what we do is we just record what the user does. We just capture the HTTP traffic and then send it back. Some customers have used other commercially available software in the past for performance testing as well. I mean, one of the things about that, there's a testing part and there's the actual creating the tests and making them be reasonable tests. And so I could go on and on about performance testing, and maybe we do that in another topic.
Yeah, I agree. Yeah, Peter, you continue. I will go.
So yeah, but I mean that is a good question. Yeah. So just to kind of go back, so when to scale. I mean a new environment, and then we can use the information we talked about earlier, the data analyses, number of users to scale it. One of the things that I find interesting is depending on the customer, some customers want to know how big a machine do I need for the next 3 years type thing, and then other ones are I'll start small and then I'll scale up as needed. So one of the things is kind of knowing where you or your IT department fall on that scale. So more and more customers are going towards the more start small and scale up, because that obviously is easier with the amount of virtualization that's going on or in the cloud and things like that are going on. But there are still some customers that want to know how much hardware do I need for the next year or two. But that's harder to do obviously, because you don't know, you can't predict the future. You don't know how big your environment's going to go, how many users are going to be using it, what you're not even sure probably what analyses might be coming into play, what Spotfire applications. So this is one thing to think about when you're sizing, is to think, like where does my company, or where do I fall on that? Sometimes it's an external pressure too. Maybe it takes 6 months to get a machine provisioned, so you kind of have to know, now what you need 6 months from now, so you don't have to go back and scale. But this seems to be changing and going more towards the more agile, side of things. But the other thing is changes in environment. So new Spotfire applications deployed, about when to scale, increases in Spotfire users, amount of data in memory, on-demand queries, whether you need to support high availability or not. Back to the clustering of the Spotfire server question. And even on the web player, high availability. Do I need to have multiple ones of those to support, in case one goes down? The other thing is the addition of streaming data. There's a good article on the community that has a white paper linked to it about streaming and scaling for streaming data. That's really important. So the other thing is, are we having performance issues in the environment? We've kind of gone through some of these. So, kind of the first thing is to determine where the performance issue might be. Could it be an external issue? Maybe the database is slow. Maybe maybe some data source is not performing well. Maybe there's something wrong with the network. Also, an environment issue. Is the hardware at capacity, memory, CPU, disk, and that's some of the things we just looked at. So the monitoring diagnostics, and then historical information in the action logs and performance counter log files. Just have a couple more slides. So as far as scaling a Spotfire, we kind of talked about this. So just kind of go through, review the items most related to scaling Spotfire. So the number of concurrent data connections via the information services. So that's the data that's brought in via JDBC and streamed through Spotfire server. So on-demand and other queries. Number of concurrent, active consumers and business authors, and to some extent analyst users, although the analyst users obviously aren't hitting the Spotfire server all the time, but if they're maybe pulling a lot of data down and doing a lot of interactions as far as data goes, then maybe they would be needed to take into account. Is high availability needed? Streaming data, this increases the amount of HTTP traffic since the visuals can be might be constantly updating. So what to scale? You can scale the Spotfire server up. You can add additional memory and CPUs. You can increase the JVM memory for Spotfire server, so it uses up more memory. There is there's a trade-off there. You don't want to make that too big, especially in some environments, because then when it comes around and does garbage collection, that may take a while. Spotfire server, this is getting a little detailed, but there's a link in the resources about increasing the max jobs and the thread pool size. So these values determine how many information services jobs as well as other kind of activities the Spotfire server in general can handle. It comes into play a lot of times, again, with the on-demand queries example I was giving earlier, where if you had a lot of on-demand queries running based on a single analysis and a user pushing a button, if you had a bunch of users doing that at once, then you might need to scale it up. You can also add additional Spotfire servers. They all use the same Spotfire database, so it's fairly easy once you've configured the Spotfire environment. You just add install the Spotfire server, and then install the additional database. You will need a load balancer with sticky sessions enabled in front of 2 or more Spotfire servers. And again, just kind of give an example, Spotfire servers tend to not be too large. We do have customers that have larger ones than these, but just as a typical, amount, 4 to 8 cores, 16 to 32 gigs of RAM. And the last, the web player. So, scaling of the web player, number of concurrent active web player users. Again, largest analysis file needed to be in memory. The complexity of the calculations, whether data can be shared or not, use of scheduled updates, how the data will be consumed. So we went through that, whether in memory, external data on demand, or streaming. And again, here there's the link to a useful article about scaling with streaming data. What do you scale with a Spotfire server? You can scale up, so you can add additional memory and CPUs. If you get too large on the web player, additional instances on the web player actually provide more throughput than just a single instance on a large web player node. And then you can also scale out, so you can add additional web player nodes. the web player nodes tend to be larger than the Spotfire server, so like 6 to 12 cores. And again, this is a typical size, not like, we have customers that have web player nodes with 256 or 512 gigs and, a lot more cores and everything, but this is kind of the typical size, just to give kind of a scale of where this fits in the size of things. You can also go, if you have a lot of small analysis files, you could have a lot of small web player nodes as well. But and last slide is just helpful links, which I think we'll provide. But that's it for what I have to talk about. If there's more questions and discussion, we can continue that.
And one thing, as you mentioned, this is Neil. We'll put these links in the video description on YouTube. We're recording this session. We'll get on YouTube later this week, and we'll include all the links that Peter has in the slides.
Yeah, and I pasted many of them in chat. I know it's becoming too many, but as Neil mentioned, we are going to post in description of the video on YouTube as well. So I guess one question I see is interesting is about AWS, and what he is asking is he need to spin off additional instances on AWS to create like a load balancing nodes. And you previously mentioned that you're using 2 server blades and to run the host. But his question was, I see there are 8 web player nodes. So he wanted to understand that, I guess, how we manage number of nodes and web players services. I guess he's, I guess he's misunderstood. They are services and not nodes.
Yeah, so these are all, this is one node, and these are all services underneath this. So this is back to my discussion about having multiple web player instances and how they affect performance. These are still there based on some testing I was doing a few months ago, and trying to see if like if you went up to, and again, these machines are fairly this machine, the web player machine also has a capability to have 128 gigs on it as well. So I was just testing to see like where kind of what if you had 8 instances, is that better than having 4 or 2? You actually don't get, after 2 instances you get a little bit of speed up with 4 instances, but it's really not much. An 8 instance doesn't give you much more. If you want to kind of a peek into the performance testing, that maybe we should have a Dr. Spotfire about my results from that. But so
True.
Yeah, this is one instance. This is one instance with this many. And again, yeah, it is useful to have more instances. In addition, this is getting a little bit off the topic of the scaling, but if you have a larger web player machine, having more instances is helpful because it has higher throughput, as well as the fact that you can support different analysis files on each one and not have them interact and interfere with each other. So.
Okay. Interesting. And now actually we are getting a lot of questions. So first question is, Peter, you will be posting the slides as well, right? So we can post the slides.
Yeah, you can post the slides. I mean, I don't know if you want to do that in a community article, how that's done with Spotfire, but we can
like community article probably better. So we will create, or Peter will create a quick short wiki article, which we will reference in the description with other links. There are some
we can do that.
questions coming in. One is about high availability. It is more efficient to have one web player service on one node or many, or ask differently based on what should I decide to have more than one web player service on one node? What is a decided?
Well, yeah. So if you look at the system requirements for the Spotfire server web player node, it says if you have more than like 50 gigs on the machine, then it's more efficient to have multiple instances on there. So if I would say if you have under 48 gigs or anything, then really only having one instance is probably good. But if you have over that, then having multiple instances might be useful. One of the things that helps with that decision is the size of the analysis files we're talking about. So when I have multiple instances on here, I can't say that this web player instance only should have this amount of memory. There's no way to box these things in. So they're sharing all the memory and all the CPU on the machine. So if you do have an analysis file that takes up, 60 or 50 gigs, let's say, and you have 64 gigs, then you should probably only have one instance on that type of in that type of environment. But if most of your analyses are small and don't take up a lot of space, then having two instances on a machine with 64 gigs does help with throughput. So it's kind of a combination of the size of the machine we're talking about and the size of the analysis files that we're talking about, kind of how that works together.
Okay, cool. Yeah, that makes sense.
I mean, the other thing about, I guess, well, let me finish, because you asked about high availability. So high availability also, I mean, if you have two instances on the same machine, you are kind of beholden to whatever happens to that machine. And again, mostly in the VM world, those have other backups to them as well. But, if you need to have actual true high availability where they have two different machines, two different, VMs that are hosting web player, then you would need to have two of those if that's the high availability. It kind of depends on how high you need your high availability to be. So
makes sense. So next one is about action log. Do action log look up at the statistic of usage of dashboard tabs and individual visualizations?
No, so it doesn't get down to the individual analysis files. You don't get that level of detail here. You can get that in what's called the memory statistics log. So I don't have any of that demo of that, but the memory statistics log will record some of the information about at least the memory that a specific analysis file is using. But the action log really is at the level of what the user is doing, and then as far as the monitoring, the system monitoring, it's really at a system level, not at a detailed analysis level.
Right. Cool. And
you do get some of that. Sorry, you do get some of that. Sorry, you do get a little bit of that. You do get a little bit of that. This is going to be kind of slow because there's lots of. You do get a little bit of that here. In fact, I've probably stressed out the machine too much right now, but if I go to the details here, you get a little bit of that here about what each user and everything is doing. But again, this is real time or concurrently, not over time. But the memory statistics log is kind of what you want to look at least give you memory information. CPU is harder to determine, but memory is in this memory statistics log.
Cool. So one more question, I guess answer is no, but can server automatically remove offline nodes if they are gone for like longer than, let's say, 2 hours or 3 hours?
There is from the Spotfire server command line, there is a delete nodes command, but you would need to, or delete node, you would need to, I don't think there's, the problem is the determining what nodes to delete type thing. You can determine, I guess you can, I'd have to look to see, but I think you can list the nodes, and I think it will tell you if they're offline or not, but it won't tell you, I don't think it tells you how long they've been offline.
Right, yeah.
So I think there's kind of components there, but there's not the whole, it would be hard to program that, I guess.
Right. And amount of questions we are getting look like we need to have one more Dr. Spotfire on this topic, but I guess this will be last two guys, and we will need to end the meeting. But is there a way to send an alert like email from server when service is not responding or down?
No, there's not a way to do that right now. No.
And the second one is another question is also a good one. How does server distribute the work? Is it a round robin, or is it depending on how much strained the resources are on specific nodes?
Yeah, I mean, that depends on a lot of different things. So let's just assume everything's equal, first off, because you do have the scheduling and routing rules that can determine where someone goes. But just assume everything's equal as far as the analysis file that's been selected and the user. Then it'll be based on the state of the either the number of instances, or sorry, number of sessions to a web player, or the state, so whether it's strained or exhausted. If the analysis file you're opening is already open on a strained node, then you will go to that node. If there's two nodes that have that both open, then it'll be based on the number of sessions, assuming the nodes are kind of equally strained or equally used, resourced.
Right.
It's kind of a high level. I mean, again, we could probably have a whole topic about that too, but
Yeah, I know. And sorry guys if we have to say somewhere that we need to end because we already like 20 minutes
yeah, so, yeah,
ahead. So thank you everyone, and thank you Peter for this session. We will meet again in January about the Python session. Thank you and have a great rest of
yeah.
your week.
Thank you. Bye.